Gemma picks one ball at random from bag A and then one from bag B. What is the probability of getting A, 2 red balls, B, 2 blue balls, and C, 1 ball of each colour? Let's look at the contents of bag A. We can see that in A there are 6 red balls and 3 blue balls, making a total of 9. Looking at B, we can see that there are 3 red balls and 5 blue balls, making a total of 8. This is a situation which lends itself very well to solution by using a tree diagram. Gemma picks one ball at random from bag A. We can represent this by the first branch of our tree diagram. So this branch represents what happens when Gemma picks from bag A. She could pick a red ball, or she could pick a blue ball. She then picks one from bag B. We draw a second branch to our diagram, which represents what happens when she picks from bag B. So this pair of branches here represent bag B. We need to have a pair of branches here because she picks from bag B if she gets a red from bag A, but she also picks from bag B if she gets a blue from bag A. This represents getting a red from bag B, a blue, a red, and a blue. Now let's look at how the tree diagram works. If we start where the pen is at the moment, we pick from bag A and we could get a red. We could then pick from bag B and also get a red. So if we end at this point, this represents red, red, meaning we get a red from bag A and then a red from bag B. If we go to the start and we pick a red from A and then a blue from B, this would be red, then blue. Going along here and then here would be picking blue, then red, and going here and then here would be blue, followed by blue. What we do next is assign probabilities to the branches. If we look at bag A, there are 6 red balls out of 9, so the probability of getting a red is 6 over 9. For a blue, the probability must be 3 over 9, since we had 3 blue balls out of 9. But note how these two numbers add up to 1. When we pick from bag A, we're definitely going to either get a red or a blue, so the probabilities on the branches must add up to 1, and this is always the case. Now let's look at bag B. There's 3 reds out of 8, so there's 5 blues out of 8, and of course these probabilities will not change if instead of getting a red from bag A we got a blue from bag A, so this is 3/8 as well, and this is 5/8. Let's now consider RR. This means that we got a red from bag A and a red from bag B. And when we see the word AND in probability, we always multiply together. So to get red red, we start here, 6/9 and 3/8 are the probabilities, so we do 6/9 times 3/8. We can see that there is some cancelling here. The 3's will go, the 6 and the 8 will cancel down, and then these 3's will go, leaving us with a probability of 1/4. So for red blue, we would do 6/9 times 5/8. Once again, we can see some cancelling here. The 6 and the 9 cancel to 2/3, and the 2 will go with the 8, giving us 5/12. Blue-red is going to be 3/9 times 3/8. The 2 3's will cancel with the 9 on the bottom, giving us a probability of 1/8. Then we have blue-blue, so we have 3/9 times 5/8. Again, there's some cancelling, and we get 5/24. Consider these probabilities. This could be written as 6/24, 10/24, 3/24, and 5/24. 6 plus 10 is 16, add 3 is 19, add 5 is 24. So these probabilities all add up to 1. This should not be surprising. Remember that 1 is the probability of a certainty. And red-red, red-blue, blue-red, and blue-blue are our only possibilities when picking two balls. Therefore, it's certain that we'll get one of red-red, red-blue, blue-red, and blue-blue, so we would expect these probabilities to add up to 1. We can now return to work out the actual questions. Part A, the probability for 2 red balls. We can read off. Red-red has a probability 1/4. For part B, 2 blue balls, the probability of getting 2 blue balls, once again we can read straight off, as 5/24. Now for part C, we want the probability of 1 ball of each colour, so we could have RB or BR. It doesn't matter whether we get the red first and the blue second, or get the blue first and the red second. Both of these options give us 1 ball of each colour. Whenever we see the word OR in probability, we know that we're going to add probabilities. So the probability of 1 of each is equal to 5/12 plus 1/8. This is 10/24 plus 3/24 which is 13 over 24. An alternative approach to this last question is that if we know that these probabilities are going to add to 1, then we could do 1 take away the ones we don't want. We don't want the probability of 2 reds, and we don't want the probability for 2 blues. Since we want 1 of each, we don't want 2 reds or 2 blues. This also will give us 13 over 24.